Assalamualaikum warahmatullahi wabarakatuh and a very good morning, albeit to the panels. I am the first presenter, Nurfarahin Binti Mohamad Ghadafy.
I am the second presenter, Filzah Syazwani Binti Muhammad Faizal.
I am the presenter, Hazieqah Binti Azman.
What is solid waste? Solid waste comes from human activities and it is a never-ending concern not only in Malaysia but all around the world. Solid waste falls into several categories, which are household, commercial, construction and demolition, and industry. The main waste component is composed of organic or food waste, paper, plastic, metal, and glass. The most common form of waste disposal is landfilling. According to the National Solid Waste Management Department, there are 296 landfills in Malaysia, where 165 are operational landfills and 131 are closed. Many landfills are reaching its design capacity and constructing new landfills become more challenging due to the population growth and land scarcity. Even though the landfills in Malaysia are in a dire state, the recyclable materials are still dominant within the waste composition. The 3R program, which is Reduce, Reuse, and Recycle, is one of the government programs to reduce waste in Malaysia. Reduce is the first step to minimize waste by limiting materials and goods. Reuse is using something again instead of tossing it in the garbage. And recycle is getting something new out of something that was used before. The data collected by the Solid Waste Management and Public Cleansing Corporation (SW Corp) from January to November 2018 placed the national recycling rate at 0.06%, which is 1,800 tons of the 3 million tons of waste collected. Study has also found that 40% of our population had negative attitudes regarding recycling programs.
So what is the issue? Malaysia produces 38,000 tons of solid waste daily. There are 165 landfills operated in Malaysia that need to accommodate 95% of solid waste. The amount of solid waste increased parallel with the development and the population growth. Before it becomes critical, it is a need to find a way to address this problem. Here, landfill in Malaysia need to be poised and isolated until it is safe, because landfill can be environmentally harmful if not controlled. As the number of solid waste increase, there are few landfills that need to be closed since they reach maximum capacity. Therefore, this study is important to forecast solid waste generated in next 1 year since Malaysia has limited space of landfill.
The objective of this study are to forecast the solid waste produced by the selected states, Negeri, Sembilan, and Melaka, in 1 year ahead, and to identify whether the selected states' landfills can accommodate the solid waste produced in 1 year ahead.
Scope and limitation. This study focuses on the volume of solid waste generation in Negeri, Sembilan, and Melaka. This is because the population and area of Negeri, Sembilan, and Melaka have not much different. Other than that, in Malaysia, the population and area of the Negeri, Sembilan, and Melaka is the smallest than the other state. In August 2020, the volume of solid waste generation of Negeri, Sembilan, and Melaka is approximately same. This study chose to forecast the volume of solid waste generation for only 1 year ahead due to limited data. The monthly data obtained is from January 2017 until the August 2020. According to Charlie, 3 years or more data needed for a good forecast. However, 5 years data or more is needed to make a great forecast. There are two limitations in this study. First is the ability of the data. Since the study area specific to Negeri, Sembilan, and Melaka, the limitation to access the data become higher. Therefore, because of this limitation, the data collection process may take longer than expected. The second limitation is on writing the report. Due to the pandemic COVID-19, The discussion to the report only can do through the online platform. Online discussion may lead to misinterpretation and misunderstanding.
This study aims to create awareness among society upon environmental problems.
Historical data is required in predicting future events. Hence, this study used secondary data. A time series data on the estimates of solid waste generated under the Solid Waste Management and Public Cleansing Corporation (SWCOP) from January 2017 to August 2020 is used to forecast the solid waste generation in Negeri Sembilan and Melaka. This data provides the solid waste generated in each state monthly.
In order to determine the trend of the data in time series, this study used a unit root test. A unit root test can also determine whether the data needs a differencing for stationary of the data. Testing a stationary of the data is important in time series analysis. The basic method to identify the stationary of the data is by plotting and visualize the data. In this study, stationary is determined by autocorrelation function (ACF) and partial autocorrelation function (PACF). The plot of ACF and PACF is called collilogram. The data is stationary if collilogram shows a pattern of decreasing to zero quickly, meanwhile the data is not stationary if the pattern decreasing is slowly.
The error measure of these 5 univariate models are measured, and only 2 models with the lowest error measure are chosen to be compared with the ARIMA model. The error measure used to determine the performance of the model are mean square error, root mean square error, and mean absolute percentage error. The alpha and beta values are set by trying a few parameters: 0.8, 0.85, 0.9, 0.95, and 0.99. This study used a try and error approach to choose the lowest error measure.
Autoregressive integrating moving average ARIMA. There are 4 steps in ARIMA. The first step is model identification. Second step is parameter estimation and selection. Third step is checking the model. Fourth step is forecast using the model. In first stage, determination of stationarity of the model and the identification of P, D and Q in the model. In second step, estimate the parameter used in the model and calculate standard error and coefficient of AR and MA terms. In third stage, residual are used to check the random and normal distribution. ACF and PACF graph are used to check the randomness of the data. In last stage, forecast the future value using the model obtained. This is the table of the role ACF and PACF. For model AR, ACF will dice down and the PACF will cut off after the lag P. For MA model, ACF will cut off after lag Q and PACF will dice down. For model ARMA, P and Q, both PACF and ACF will dice down. Same goes to ARIMA PDQ, ACF and PACF will dice down. Model validation. This study used MSE and MAPE. MSE is mean square error, while MAPE is mean absolute percentage error. MSE commonly used for comparing the forecasting model performance, while MAPE most widely used unit frame measure and easier to understand.
The graph shows the total solid waste generated in Negeri Sembilan from January 2017 to August 2020, and it can be seen that there is no obvious pattern in the data series. From July 2018 to July 2019, it can be seen that the volume of solid waste generated in Negeri Sembilan is increasing tremendously compared to previous months and reduced in early 2020. The decrement may due to people stay at home during the Restricted Movement Control Order (RMCO). This graph shows the total solid waste generated in Melaka, and it can be seen that the waste increased majorly in May 2018. This increment may due to the start of Ramadan for all Muslims in Malaysia. People tend to waste food during this month. The graph also shows there exists irregularities pattern in the data series. The occurrence of random short-term memory, which affects the trend and later returns to the normal level, can be seen from March 2020 to May 2020. The sudden decrease in the solid waste generated during that period may due to the restricted movement control order implemented to curb the global virus outbreak COVID-19. During that phase, people are obligated to stay at home. All outdoor activities are not allowed, and these contribute to less solid waste generated during that period. Both data series for Negeri Sembilan and Melaka is stationary since growth or decline pattern does not present. Both autocorrelation function SCF and partial autocorrelation function PSCF do not show significant change.
This is the univariate model testing result. After comparing the value of error, the model with lowest error is single exponential and hot winter. The first table is the value of MSE and MAPE for Negeri Sembilan of single exponential 0.8 and hot winter 0.8. The second table is the value of MSE and MAPE of single exponential 0.8 and hot winter 0.9.
Based on the original of Negeri Sembilan and Melaka graph shows no presence of seasonal effect. Next, the ACF and PACF for Negeri Sembilan and Melaka shows no decaying pattern and no value surpasses the maximum significant value. Moreover, unit root test also shows that the ADF value are significantly lower than all three critical value given, which shows that Negeri Sembilan and Melaka are both stationary. In order to determine appropriate fitted model in the time series data, this study measures model performance based on MSE and MAPE. There are 6 models chosen to obtain best model for both data, which are ARIMA 102, ARIMA 103, ARIMA 202, ARIMA 203, ARIMA 302, and ARIMA 303. In comparison of ARIMA model and univariate model, ARIMA model has the lowest MSE and MAPE value, which indicates that ARIMA are the best model to forecast solid waste generate for Negeri Sembilan and Melaka. For model validation, in selecting the best ARIMA fit model are determined by lowest MSE, MAPE, Lejong box Q statistics, R-square, Watson, and normalized BIC. In the meantime, model parsimony also taken into account in choosing the best model. In conclusion, ARIMA 202 and ARIMA 103 are the best model to analyze solid waste generate for Negeri Sembilan and Melaka respectively.
As all models are stationary and no differentiation is needed, thus the best model to forecast the solid waste generation in Negeri Sembilan and Melaka become ARMA 22 and ARMA 13 respectively. This graph shows the estimated solid waste generation in Negeri Sembilan from September 2020 to August 2021. The maximum capacity of the landfill in Negeri Sembilan is 35,700 tons per month. Comparing the value of the estimated solid waste generation in Negeri Sembilan and the maximum landfill capacity, the landfill might not be able to accommodate the solid waste generation in Negeri Sembilan in the future. The average of the solid waste generated in Negeri Sembilan is 23,989.58 tons, and this already comprises 2/3 of the maximum landfill capacity every month. As mentioned before, the best model to forecast the solid waste generation in Melaka is ARMA 13 model. The graph shows the estimated solid waste generation in Melaka from September 2020 to August 2021. The maximum capacity of the landfill in Melaka is 22,800 tons per month. The average of the estimated solid waste generation in Melaka is 20,367.72 tons, and this already comprises 89% of the maximum landfill capacity every month. The graph shows the consumption of the estimated solid waste generation on the landfills in Negeri Sembilan and Melaka. The estimated solid waste generation in each state is expected to reach the maximum landfill capacity in both states, respectively. It can be seen that more than 50% of the landfill in Negeri Sembilan is consumed by the estimated solid waste generation, while in Melaka it is more than 70%. It can be concluded that the landfill is nearly full, and this is only for 1 year. Imagine what will happen in several years ahead. Thus, appropriate measures should be applied to avoid overflow of waste in both states, respectively.
For conclusion, this study are using ARIMA for forecast the volume of solid waste generation for the next 1 year. ARMA 2 and 2 and ARMA 1 and 3 models are selected respectively for Negeri Sembilan and Melaka. Through this study, the volume of solid waste generation for the next 1 year is expected to reach the maximum capacity of the landfill areas. It is worrisome that no more landfill will be able to accommodate the future solid waste generation. Therefore, everyone should take action together in order to reduce the solid waste generation in future. As the recommendation to reduce the solid waste generation in the future, there are 3 recommendations to solve the problem. The first recommendation is restriction on the use of plastic bag and plastic food container. Nowadays, the restriction on use of plastic bag only on Saturday in the shopping complex. However, they should restrict the usage of plastic bag not only on Saturday but every day. The second recommendation is use the grocery bag. The government should enforce the instruction on the use of grocery bag instead of plastic bag. The last recommendation is everyone should practice the concept of 3R. 3R is reduce, recycle and reuse. Everyone have to reduce the amount of solid waste from home and reuse the container or plastic bag that can be used again. And they should recycle the solid waste that can be recycled and throw the solid waste according to the recycle bin color. Finally, the study also recommended forecast using a large number of data in order to improve the forecast period in future to get the best forecast value.